Friends, welcome back to Wisdom Academy YouTube channel. In the previous video, you have learnt about Orsted's experiment to find the magnetic field due to a current carrying conductor. I also talked about how to find direction of magnetic field. In today's class, I will talk about another law which is called as Biot-Savart Law, or it is called as Bio-Savart Law also. So some places they will pronounce it as Bio-Savart's Law. We generally say as Bio-Savart's Law. So in this Bio-Savart's Law, these two are two different scientists who found the magnetic field due to a current element. So one important thing to note here is current element. So current element, often represented by dl, is a small portion of length which carries the same current what is carried by the complete wire. So suppose I have a wire here like this. So in this wire of complete length, if I take the small portion, suppose the current goes from here to here, and in this portion also current will travel like this. So this small length will be called as dl. So Bio-Savart, they found what is the magnetic field due to this dl at any point P near to it. So at this point P, they try to find what is the magnitude and direction of magnetic field. So let this point P be at a distance of r away from this dl portion. Now you can say that theta is the angle made between this current element and r vector. So r vector is the position of P from the dl. Theta is the angle made between dl and r. From a series of experiments conducted by Biot-Savart, they could find that this magnetic field at B, small magnetic field dB, will be proportional to some quantities. What are those quantities? First quantity was current. So the more current was flowing, the more magnetic field was produced, and the less current was flowing, less was the magnetic field. So you could formulate that the magnetic field is directly proportional to the current flowing through the wire. Second thing what he found, that this magnetic field was also proportional to that current element length. So suppose the current element length is more, there was more magnetic field, it was less, there was less magnetic field. So I can write dl. It was also found that this magnetic field is directly proportional to sine of the angle between the current element and the r vector. So I will say that angle is theta, so sine theta. And it was found that magnetic field was inversely proportional to square of distance of that point from the current element. So I will write dB is inversely proportional to 1 by r square. So all these sets, if you ask me how he got from a set of experiments where he would have taken n number of times the current element and passed various amounts of current, took a different lengths, kept the point at various positions, and he could draw these conclusions. When we combine all these things together, I get dB is proportional to I dl sine theta by r square. To remove proportionality, I have to add a constant, and that constant is k. dB is equal to k I dl sine theta by r square. Experimentally, k was found to be equal to mu naught by 4 pi. So mu naught is permeability of free space. Don't confuse between permittivity and permeability. This is called as permeability. So it is permeability of free space because it is not. So what we found, that k was dependent on the medium. So what is the medium present between P and this dl was governing the magnetic field. So that is called as mu naught by 4 pi, permeability of free space. If suppose you replace that free space with some medium, it will become mu naught into mu r, that is equal to mu of that medium. So already this kind of things we have seen in epsilon naught also, same way. So mu naught by 4 pi, the value of mu naught is equal to 4 pi into 10 to the power minus 7. So when you find this value, it will come to be 10 to the power minus 7, right? This is the scalar representation, or I will say magnitude of magnetic field. So we came to know that magnitude of magnetic field is mu naught by 4 pi into I dl sine theta by r square. Suppose I want to write this magnetic field in a vector form, because magnetic field is a vector quantity. If you want to write this magnetic field in a vector form, then how we will write? dB is equal to mu naught by 4 pi. I know that I is scalar quantity, current is scalar quantity. I think you are clear in that from the last chapter. dl is vector quantity obviously, and I can cross multiply by r, and additionally I will add one r down, r cube. So why I am doing this? Because I know that a cross b gives you ab sin theta. So here it will become dl r sin theta, r and this r will get cancelled. So you will get the same expression what you got from here. So this is the vector representation of magnetic field. So in vector form we can write that magnetic field vector is equal to mu naught by 4 pi I dl vector cross r vector by r cube. Please remember this, it is one of the very important derivations, or I will say expressions, which will be used in forthcoming all the other applications. So Bio-Savarts or Bio-Savarts has lots of applications, we will see one by one. The SI unit of magnetic field is Tesla. So the SI, you can make a note of this, SI unit of magnetic field is Tesla, represented by capital T. Yeah, it is on behalf of Tesla scientist. Fine. Now we are going to compare Biot-Savart law with Coulomb's law. See, Biot-Savart law gives the value of magnetic field, that is equal to mu naught by 4 pi I dl cross r by r cube, whereas electric field can be found by using Coulomb's law, and that is equal to dE is equal to k q by r square into r cap, if I am right. So kq by r square was the electric field by using Coulomb's law, and mu naught by 4 pi I dl cross r by r cube is the magnetic field by using Bio-Savart law. Now I am going to draw some comparison between them, whether they are having some similarities or differences. Let us see that similarities and differences. First of all, similarity, if I see, the first and the foremost similarity is that they are inversely proportional to square or distance between them. So first point of similarity is they are both are inversely proportional to square of distance between them. Second similarity can be they both are long range field. I will write it here for you. The similarity point first I am writing. So similarity, if I want to write, the first point of similarity can be they both are inversely proportional to square of distance, and second point are they both are long range field. Let us see what is the point of dissimilarities between them, what are the points of differences between them. So can you please try to see the equations and say what are the difference point between them. One thing you can say that here I am getting dB by some vector product. So it has a vector source, but it has a scalar source because there is no vector quantity here. So first thing is magnetic field has vector source, whereas electric field has scalar source. The first point of difference between them is it has a vector source and it has a scalar source. Another point of difference between them would be their directions. So you know well about the direction of electric field. So suppose there is a charge here, suppose there is a charge plus q, and you want to find electric field here, it will have up direction in this way. If it is negative charge, it will be direct, so it will be directed towards the charge. So it will be directed either away or towards the charge, but in the same plane. Can you see it is in the same plane? Nothing happens in the opposite planes. So it happens only in the same plane. So I can write about electric field that electric field direction is in the same plane. What about the magnetic field direction? So direction of magnetic field, you have learned about this even in 10th standard, and you will learn in more detail when I go forward in this. So what happens, suppose this is a wire carrying a current. So you want to find direction of magnetic field produced by this wire, you have to hold the wire in right hand and your 4 fingers in which direction they are pointing, that direction will be the direction of magnetic field. So if the current is going in this direction, then at this point the magnetic field will be inside. See, my hand is tending to make it go inside. So here I will write into the paper. So into the board or into the plane. Why into the plane? The direction of magnetic field will be inside the plane. But if I see on this side, it will be outward. So it will be represented like one dot. A dot means outward, outside the plane, and cross means into the plane. I hope you are understanding. There is one more way of saying it by using right hand screw rule, because since it is a vector product, we know the vector product, the direction of the vector product will be given by right hand screw rule. So suppose I want to move from dl to r. Suppose if you remember that derivation, I told you this is dl and this was r. Theta was the angle between them. This was r, this was dl. So how do you find direction of magnetic field? If you want to find direction of magnetic field at this point, then you have to come from dl towards r, and while doing so, wherever your thumb represents where it's going inside, that will be the direction of magnetic field. So if I come from dl to r, I will see that my thumb is going inside, whereas when I go from r to dl, it will come outward. So it is dl cross r, so it will be inward. So this is one way of telling about the direction of magnetic field. Another way is like this: hold the wire in your right hand, and the four fingers where it is going, that will represent the direction of magnetic field. So direction of magnetic field direction is in perpendicular plane, whereas direction of electric field was in same plane. I hope you are understanding. Electric field, if a charge is present here, electric field will be in the same plane, but magnetic field, it will be either inside or outside. So it will not be in the same plane. I hope you are understanding. So inside means it is like this, outside means like this. So this is the difference between Coulomb's law and Biot-Savart's law. Let us see one question based upon this. An element dl dx I cap is placed at the origin and carries a large current of 10 ampere. What is the magnetic field at y axis at a distance of 0.5 meter? Okay, so here I have some element. Let that element be dl here at the origin. Let this be dl, that is equal to dx, and I cap, that means it is current is flowing from here to here. Like this, the current is flowing. I cap, like this is the x axis, this is the y axis. Here it will be having j cap. I hope you know about this. And then they are asking you to find what is the magnetic field at some point here, and that is at a distance of 0.5 meter from the origin. And they have given the value of dx also, that is 1 centimeter. That is equal to 1 centimeter is 10 to the power minus 2 meter. Fine. So now first we have to find the value of magnetic field. So what is magnetic field magnitude? We know that magnitude of electric magnetic field is equal to mu naught by 4 pi into I dl sin theta by r square. So this value we know it is 10 to the power minus 7 into what is the current? Current is given as 10 amperes. What is the dl? dl is dx, and dx is 10 to the power minus 2. And sin, what is the angle between dl and r? This is the r vector, right? Because this is the direction. This is the direction and this is this. So the angle between them is 90 degree. So sin 90 degree by distance is 0.5. So 0.5 square. So when you solve this, you will get the value of magnetic field's magnitude. So what is the magnitude of magnetic field? That will be coming if you solve this equation. It's a very simple equation. You please solve it and you will get the answer. Important thing is, what is the direction of magnetic field? So if you see here, the direction of magnetic field will be given by dl cross r. We know that dl cross r, if you do, you will get the direction of magnetic field. So what is dl? dl is dx I cap, and what is r? r cap is here. So r cap is y direction. So I will write y into j cap. So it will be coming as dx y I cap cross j cap. So what is I cap cross j cap? By the knowledge of vector, you can say it is k cap. So it will be dx y into k cap. So k cap means which direction? Z direction. So it will be like outward. So I will write one dot and I will put circle. That means it is outward. So out of the plane. It's something like this. So direction of magnetic field is in this direction. I hope you are understanding what I am trying to say. Without doing this also, since the the current is in this direction, dx is in this direction, or dl you can say, r is in this direction. So by seeing that, you can see this is the direction of current. So the magnetic field will be outwards. That I am using basic rule, where right hand thumb rule, where I am keeping the current in the right hand and checking the direction of magnetic field, right? Next, let us see what is the relationship between mu naught and epsilon naught. So, we know that epsilon naught is the permittivity, epsilon naught is permittivity of what? Of free space, and we know that mu naught is the permeability of free space. I am interested in finding what is the relationship between these two quantities. For that, I know 1 by 4 pi epsilon naught is equal to 9 to 10 power 9. From here I can write that 4 pi epsilon naught is equal to 1 by 9 to 10 power 9. Also, we know that mu naught by 4 pi is equal to 10 to the power minus 7. So, what I will do, let this be question number 1, let this be question number 2, I will multiply both. So, if I do 1 into 2, I will get 4 pi epsilon naught into mu naught by 4 pi is equal to 10 to the power minus 7 divided by 9 into 10 to the power 9. So, these two gets cancelled and this goes above. I get mu naught epsilon naught is equal to 1 by 9, or this comes down, I can write it as 1 by 9 into 10 to the power 60. So, can you see that if you do, see here mu naught, this whole quantity I can write it like this, 1 by 3 into 10 to the power 8 the whole square. I will get the same quantity. Why I am adding this? Because this is the speed of light. So, I get from here mu naught epsilon naught is equal to 1 by c square. In other words, I can write c is equal to 1 by root over epsilon naught mu naught. Very important relationship between permittivity and permeability of free space, very useful for the competitive examinations, right. So, in today's class, what you have learned? You have learned about Biot-Savart law. One important thing today what you learned is about the current element, and we got to know that magnitude of magnetic field at any point for due to a current element is given by dB is equal to mu naught by 4 pi I dl sin theta by r square. You also saw the vector form of that. You came to know SI unit of magnetic field is Tesla, and I also compared Coulomb's law with Biot-Savart law, and finally I made a relationship between permittivity and permeability. Please like the video, subscribe the channel and share with your friends. Thank you.